everybody. Let's talk about graphing rational functions. So this is going to be my first of 3 videos on graphing rational functions. So I'll hit a lot of the basics in this video, and then in my second and third videos, I'll look at a little bit more complex equations. So real quick on the basics, this is a basic rational function. So when we're talking about rational functions, we're talking mostly just about fractions here. So we're graphing y equals 1 divided by x. This is the most basic as we can get as far as a rational function. So this graph, if you plot it out, is going to look, and this is a rough sketch by me. This isn't incredibly precise on every single point, but this is the graph that you get. So what we have is we call them branches. So there's a branch in this bottom left corner, and there's a branch in this top right corner. Okay, so what's going to happen is you got a branch in the bottom left and the top right, and we'll talk about how those kind of move around. Another point that's super important here, it doesn't really have a full mathematical term, but it's something I point out, is kind of where the center is. So if you kind of look at, you got a branch up here, a branch down here, there's a center point that everything is kind of focused around, and currently it's at 0, 0. Now here's why that center point is important. If you see here with my highlighter, I have a highlighter going to the left and a highlight coming straight down. What these are asymptotes. So this is a horizontal asymptote, and this is a vertical asymptote. What they are is they're not really part of my graph. They're essentially imaginary lines that my graph is going to get very close to. Okay, it can cross an asymptote, doesn't happen very often, but our graph's going to get very close and get nice and snug to those asymptotes. So what happens is if you could find out where the 0, 0 point, the center point is, which is at 0, 0, you're going to have a vertical asymptote that goes to that point and a horizontal asymptote that goes through that point. Okay, so then our graph kind of goes along the asymptotes. Here's why this center point, or where the asymptotes crisscross, is super important. What we're going to do is we're going to identify the domain, the range, the horizontal asymptote, and the vertical asymptote. For a horizontal asymptote, they're just looking for what is the equation of this horizontal line. Now, it can be tough to think about how do you write an equation of a horizontal line, but if we think back to Algebra 1, you think of HOY, H-O-Y, and VUX, V-U-X. HOY represents horizontal, 0 slope, and y equals for the equation. Where VUX is, vertical lines have an undefined slope and use x equals for their equation. So if I want a horizontal asymptote, I need to write the equation. It's going to be a y equals. Now here's where this center point comes in handy. The x, y values of that center point are going to help you with the horizontal and vertical asymptotes. So I want y equals, well, y equals 0, because that is the y value of that center point. And when I want the vertical asymptote, I want the x value here. So x equals 0. Those are the equations of the horizontal asymptote and the vertical asymptote. The other follow-up question that we're going to address is domain and range. And we've talked about this a lot before. Remember, the domain is what are all the x values that I can plug into the function. The range is what are all the y values that I can get out of the function. So in this function, we can plug in just about anything we want for this x value. So what we say is all real numbers. You could plug in just about any x value that you could come up with into this equation. But there's one x value that we don't want. So we're going to say x cannot be equal to, the one number we don't want is, we don't want, and it comes again from the center point, we don't want x to be 0. Now here's the reasoning for that. If you plug a 0 into this function, you're going to have 1 divided by 0. And if we divide by 0, we're going to have some issues there because we can't divide by 0. So we could plug in any x value we want except for 0. So for the range, it's asking, all right, so you're plugging all of these x values in. What are the y values that you can get out of it? Well, I can get all real numbers. And another way to represent that is the symbol for all real numbers. I could get about just any y value that you can come up with, except there's one y value that no matter what we do, we're never going to get. We're never going to get 0. And guess where I got this value? also from the center point. So yes, they're all zeros here, but they come from the center point where those asymptotes crisscross. So I can have all x values except for 0. I'm going to receive all y values except for 0. So this is a basic rational function. What we're going to look at is a little bit more complex rational function. So what I have is f of x equals -2 divided by x plus 4 minus 2. Now how we're going to graph this is we're going to connect this to transformations. This function is set up with just a constant up top, and we'll call that a. On bottom is x minus h, and in the back is plus k. So we've talked about transformations of functions before and what a can do, what h can do, and what k can do. So when I see a -2 in place of a, I know that's a reflection over x. I know it's a vertical stretch by 2. When I go to the bottom, that's the x minus h part. If I see an x plus 4, I'm not going to move to the right 4. Instead, I'm going to move left 4. So we're going to slide everything left 4. Then finally, the k in the back of -2 is going to slide everything down 2. So here's how knowing the transformations is important. So we're connecting kind of some prior knowledge there. Is we know this center point is supposed to start at 0, 0. So if we apply the transformations there, if I reflect it over the x-axis, well, I'm going to stay right there. If I vertically stretch it by 2, we're going to stay right there. If I slide it left 4, well, I moved to left 4. If I slide down 2, then I'm going to go down 2. So left 4, down 2. That's where my center point would be. And it's pretty important that I do note this off to the side what the coordinates of this are, because I'm going to use them in a little bit. The coordinates here would be -4, -2. Now what I'm going to do is I'm going to be able to take my highlighter and draw a horizontal asymptote through there, as well as a vertical asymptote. The only other thing I have to do is I have to draw in my branches here. So remember in the original graph, most basic rational function, we're in the bottom left of our asymptotes and we're in the top right. But if we go to the transformations, it says reflect over the x-axis. So we need to reflect everything around. So instead of being in the bottom left and the top right, we're going to flip in this direction. So we're going to be the top left, bottom right. When we vertically stretch by 2, the effect that's going to happen there is typically our branches are going to come in pretty tight to that center point. When you stretch it by 2, you're just going to space it out and not come in as tight. So I'm going to start near one asymptote and jump across to the other asymptote. If I wanted to get super precise here, I would just use a graphing calculator to plot some points, but I'm just doing rough sketches here. And I need to be in the top left, so I'm going to start very close to the asymptote and then jump across to the other one. There's my graph. For follow-up questions, I got to figure out the domain, range, horizontal asymptote, and vertical asymptote. So I start with my asymptotes first, then I work to the domain and range. Horizontal asymptote, I'm just looking for the equation of this horizontal line. Horizontal asymptote should make you think Hoy, H-O-Y, the y value of that center point being -2. So the equation of this horizontal asymptote is y equals -2. Vertical asymptote, I'm thinking Vux, V-U-X, the x value there being -4. That is the equation of this vertical asymptote. Finally, domain and range, so we're figuring out what x values can I plug into this function, and then range, what y values can I get out of this function. So I could plug in all real numbers. I could plug in just about any x value you could think of, except there's one that I can't plug in. I do not want x to equal, again from that center point, -4. The reason for this is if you plug in -4 into the denominator here, you're going to end up dividing by 0, and we do not want to do that. For the range, you're going to get about every single y value you can think of. So I'm going to do all real numbers, except there's a certain y value that no matter what you plug in for x, you're never going to get this as an output for y. So y will never equal, and again from our center point, -2. So this was graphing rational functions. For these, when you have just a basic constant on top, and the x is a degree of 1 on bottom. So it's just a plain old like x plus 2 or an x minus 2. Follow the transformations. Figure out, is there reflection? Are we vertically stretching? Are we sliding left or right, sliding up or down? And then move your point from 0, 0, wherever it needs to go. Find your center, and you're on your way. Again, this was Graphing Rational Functions 1. I have 2 more videos on graphing rational functions to follow.